So in this video of 7.2, we're going to be explaining the odd ones, WSGI. And this is reviewing those last two rules of canceling and also moving negative exponents to the other side. So on number one, you have to know, or you have to realize that there's 5 5s up on top and there's 2 5s on the bottom. I mean, to really understand it, you should expand it. 1, 2, 3, 4, 5. And on the bottom you have 1, 2, right? So what ends up happening is this 5 cancels with that 5, this one cancels with that one. What's left over? There's 3 5s up on the top, so your answer is 5 to the third. And it's pointless to put it over 1. Since there's nothing left on the bottom, you could put it over 1, but that's kind of pointless because anything divided by 1 is itself, right? So 5 to the third is the answer. Now in the back, they might, on your solutions, they might write it like that, but they probably expanded 5 to the third. 5 times 5 is 25, and 25 times 5 is, final answer, 125. I mean, technically either answer is acceptable. It just, if you could do it, you might as well do it. So let's jump to number 3. So this first half of this worksheet is all about canceling. All right, the second half is about moving negative exponents. So what cancels on this second one, or on this number 3? What cancels? How many p's?
1.
There's 2 of them down here, and there's 5 of them up here. So all 2 of these guys are going to disappear with 2 of these 5, and there's going to be 3 left over. So when you guys ask me, do I need to show my work? There's really no work to show except maybe for canceling and drawing arrows, right? Like if things move or if you distribute. So in this case, what could you show? You could show that all of these 2 p's cancel out with 2 of these and write a 3 up here because that's what's left over. 5 take away 2 is 3. That's why there's 3 left over up there. The n's, this entire n on the bottom cancels out with 1 of these 4, so there's 3 left up on top. So I mean, that's the only work you could possibly show, right? Canceling things out. Or with negative exponents, circling them and drawing arrows because you're moving them to the other side. But anyway, right here, that's the answer. P to the third, n to the third, and it's over what? What's left on the bottom? Nothing. So you could put a 1, but that's kind of pointless because anything divided by 1 is that value. So let's not even put that. Now, if you don't have anything left up on top, then you would have to put a 1 up on top. But when there's nothing left on the bottom, you don't have to put over 1. I hope that makes sense. Let's jump to number 5. So the x's on number 5, there's 5 x's on top, 5 x's on the bottom. All 5 x's cancel out with all 5 x's. See how I scratch the whole thing? Scratch the whole thing, it's gone. I don't have to worry about it anymore. Now the y's, well, there's 2 y's on the bottom. I'm going to cancel out both of those y's with 2 of the 3 that are up on top. You see this 3? That's all I scratch out. I do not scratch out this y because there's still a y left. If you cancel out 2 of them from these 3, there's only 1 left. So you could put a 1 if you want. You don't have to because there's already 1 y right there. So what's your final answer? Just that 1 y up on top. You don't need to put it over 1. That's your answer. Your answer is simply y. Let's jump to number 7. On number 7, do we have x's on top and on bottom? Yes. We're going to cancel out this x with this x. So let's draw a line right through it. It's gone. There are no more x's, right? And how about y's? Well, there's 4 of them on the bottom and there's 6 of them up on top. So all 4 y's cancel out from the bottom. And only 4 of the 6 cancel out on top. That's why I don't draw a line all the way through. I only cancel out 4 of the 6. So how many are left up here? 2. And that is your answer. What do you have left? You have a y squared over nothing. So you can put a 1 if you want, but that's just your answer, y squared. That's your answer for number 7. Let's keep going. Number 9. So to explain number 9, you have parentheses with an exponent on the outside. And we know from the very first couple of rules that we learned of exponents that when you have parentheses with an exponent on the outside, what do we do with this outside exponent? We distribute it into each and every term, right? So yeah, it's going to multiply with the other exponents. So you're going to take, so again, the only work you could show here is distributing the 3, circling it and drawing arrows. But how about this? Before doing this, before putting a 3 right there, before doing that, okay? Let's not do that yet. Before doing that, is there anything that's on the inside of the parentheses that we could do?
Yes, you could
Cancel. So let's cancel, right? What could we cancel?
P and R.
The P's and the R's. How many P's are on the bottom? And all of these 2 P's, both of these P's are going to cancel out with 2 of these 4. So you're going to have 2 left over up on top. And the R's, both R's on the bottom are going to completely cancel out with 2 of the 4 up on top. So there's going to be 2 left. So that's the only work you could really show. Now after that, we're going to use that rule that we mentioned before, that when you have parentheses with an exponent on the outside, let's distribute it into each term. So you could have distributed first and then canceled, but it's easier to cancel first and then distribute. Many roads to the same place. So we're going to take this 3, let me do it in blue, take this 3 and distribute it to each and every term that's left over right now. So I'm going to put it on this 4. I'm going to put the 3 and multiply it by that 2. Multiply it by that 2. I'm going to put it on this 3 down here, and that's about it. Everything else is gone. So let's write our new answer down here. We're going to have a 4 to the 3rd power. We're going to have a P to the 6th power and an R to the 6th power. And on the bottom, we're going to have the 3 to the 3rd power. Now, the only other thing that we could do to make this answer nicer is to do the 4 to the 3rd, which is really 4 times 4 times 4. And if you do that with a calculator, 4 times 4 is 16. 16 times 4 is 64. So our final answer is going to be 64 P to the 6th, R to the 6th over 27, because 3 times 3 times 3 is 27. See, it's not that bad. Let's move on to number 11. Number 11, same thing. What would be the first step we do? I mean, we could distribute the 4 to each and every term, but we're going to get bigger numbers in here. So you might as well simplify the inside first, if possible. So what could you cancel on the inside? The R's. How many R's are on the bottom? There's 5. All 5 of these R's are going to cancel out with 5 of these 6. And how many will I have left up on top? 1. So you can put a 1 if you want. And the N's. The N on the bottom is going to completely cancel out with 1 of these 3. Which means there's going to be how many left? 2. So put a 2 right there instead of the 3. So that's the only work you could show, canceling and then also distributing, circling the number and drawing arrows to each and every term. Okay, so our final answer, well, not final, but almost final answer is going to be 3 to the 4th, R to the 4th, N to the, and right here we have 2 times 4, that's going to be 8, over 2 to the 4th. I'm not sure, do they leave it like that on the answers on the back of the worksheet? Or do they actually do 3 times 3 times 3? They do it. So what's 3 to the 4th power?
81.
81. And then we have the R to the 4th, N to the 8th, over 2 times 2 is 4, times 2 is 8, times 2 is 16. So there's our final answer, 81, R to the 4th, N to the 8th, over 16. Let's go to number 13. Whoops, no 13. Anyways, the bottom half is 1 through 12, just like above, it was 1 through 12, and the top part was all about canceling, and this bottom one is all about moving negative exponents to the other side. So I'm going to do the odd ones on this bottom half. So the only work you could show here, guys, is circling whatever has a negative exponent and then drawing an arrow up to the other side, okay? So my new problem, the 2 squared is still up there, but now I have a 2 to the 3rd power right in front of it, and they're being multiplied together. So on the numerator, I really have 2 to the 3rd times 2 to the 2nd. And rule 1 says that when you're multiplying 2 terms with the same base, we take those exponents and just add them together, okay? So our answer is going to be 2 to the 5th over 1. But you don't need the over 1, so that's your answer, 2 to the 5th. Now, like I said, it depends on the answers in the back or the multiple choice answers on the quiz or test. They might write it as 2 to the 5th, or they might actually go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So they might write it as the answer 32. Let's move to the next odd one, number 3. So again, the only work you could show is this. Circle it, whatever has a negative exponent, draw an arrow moving it to the other side. So ladies and gentlemen, when I move that down, obviously the p to the third did not move at all, but that p to the negative 8, when you move it down, it becomes p to the positive 8. And what's left over up on top? A 1. Since there's nothing left up there, you have to put a 1 up there. If you don't put that 1, it's going to be wrong. Okay? If there's nothing left on the bottom, yeah, you don't have to put the 1. But if there's nothing left up on top, if you move that and there's nothing left up here, you have to put a 1. Okay? And now, again, rule 1, you're going to add 8 plus 3, and you're going to get 11. So your final answer is going to be 1 over p to the 11. That's your answer for number 3. Let's jump to number 5. Yes, it's getting more fun because they're throwing in other rules. So you're not going to start with, I want to grab this one and move it to the other side. You can't really do that yet because it's inside parentheses, and on the outside of the parentheses you have a 0. So what does that tell you about all this up here? That becomes 1. It all cancels out. It just becomes 1 because the rule says anything to the 0 power is equal to 1. And this whole thing, it's included in parentheses. So this whole thing equals 1. So you could just like scratch it all out, and right next to it you could put a 1 up there because that's what it really is. There's really just a 1 up there. Now on the bottom, what could I do? I have a w to the negative 1 power. I'm going to circle that, and I'm going to draw an arrow up. Okay, so the w to the negative 1, it goes up and it becomes w to the positive 1. Right? On the bottom, we still have that 4 that didn't move, and we still have that y squared that didn't move. So the only thing you could do to clean this up a little is not write the 1 right here and not write the power of 1. That's simply 1w, simply a w. So your answer is w over 4y squared. That's your answer. Let's jump to number 7. Fun stuff. What rule could we apply here? Could we cancel?
Yes.
Remember, the only time you could cancel is if you have like x's up on top and x's on the bottom. Now, you might think that you have an x on the bottom, but doesn't that have a negative exponent? So what are you supposed to do with negative exponents? Switch them to the other side. So is this x really on the bottom? No, it belongs up on top because it's a negative exponent. So let's start with that. Let's circle this guy and draw an arrow up. And we're going to put it right in front of this x to the 4th. And how about that other rule, anything to the 0 power is 1? Well, the y is the only thing that has a 0 power, so you could scratch that out because that becomes 1. So our answer so far is going to be the x squared. When you move it up, it becomes positive. And you also have that x to the 4th that you didn't move at all. It's still up there. And there's nothing left on the bottom. You could put a 1, but at the end of it all, you're not going to write it on your answer. Okay? You don't need the 1 on the bottom. So all we're really doing here is x squared times x to the 4th. That is rule 1 of exponents. So your final answer is what? X to the 6th. There you go. Let's jump to number 9. Okay, so number 9 has a bunch of different rules, and you could choose which rule you want to start with. So you said that you want to start with distributing that exponent. So this is the only work you could show. Circle that 2, draw an arrow on the 3, on the r, and on the t. So up on top, let me rewrite my fraction. Up on top, I have the 3 squared, which will later be 9, r squared, t squared. Okay? And let me rewrite everything so I don't get confused. The u to the negative 4 is still up there. The r to the negative 1 is down there. The t squared is right there. And the u to the 7 is still down there. Okay? So I'm not going to do too many things on one problem because then it'll get really ugly and I might get confused when I jump to my answer. So what would my next step be? Okay, you applied one rule. What other rule could I apply? Canceling? All right. Cancel what? The r's and the t. Okay, how about the t's? Let's start with the t's. That says t squared right there. and this is t squared. Now the reason why we're able to cancel the t squared over t squared is because when you divide something by itself, it cancels out. So 2 t's completely cancel out with 2 of these t's. Now you might be thinking, I want to cancel out r's, but the problem is this r is really not on the bottom. You got to switch it, right? So that's a different rule that you have to apply. So let's apply the negative exponent rule. So circle it and then draw an arrow up. I want to put it right in between the 3 squared and the r squared. Okay? And the u to the negative 4, I'm going to circle it and draw it right here, or rewrite it right there after the u to the 7th. So I'm going to rewrite this thing, obviously, because it's getting ugly. So instead of 3 squared, what am I going to write? Instead of 3 squared? 9, okay? And I have the r to the positive 1 because I moved it up, and I still have the r squared that was originally up there. And there's no more t, and this u, I'm not going to write it up there, it's going to go down. So on the bottom I have the u to the 7th, and I'm moving the other u to the negative 4th down, so that's going to become u to the positive 4, u to the positive 4. Bless you. Now the only other thing to do here is rule 1 of exponents, which is add your exponents when you're multiplying with the same base. So you're going to be able to add 1 plus 2 and get 3. So your final answer will be 9r to the 3rd over u to the, if you add that, you get what? 11. So there's your answer, 9r to the 3rd over u to the 11th. Now, a lot of people try to do all the steps right here, right? They start, like, let me show you what you could have done, but I'm telling you, I don't recommend it because it could get confusing. If you, start doing all of this, right? And then you try to do everything right here, it'll get confusing. So I recommend do a couple of steps, 1 step or 2 at most, and then rewrite it the way we did on this problem. Let's move on to number 11. Number 11 looks crazy, right? And normally we start with the inside of the parentheses, right? So some of us might want to move this up, and then you'd have to combine it with that one, and then you'd be able to cancel the 4 and the 8 and put a 2. But that's a waste of time. Why is that? Why is all that a waste of time? Because everything, this whole thing is to the power of 0, and we know the rule says anything to the power of 0 equals 1. So that's your answer, 1. So if you started doing the work on the inside, you just wasted time, because anything to the power of 0 equals 1. Now, don't get me wrong, if this would have been a 2 out here or a 3, then yeah, you have to do all the inside work first and then distribute the 2 to each and every term. But right here, because the power of 0, the answer will be 1. So that's about it for this worksheet. I'll make another video later doing the even ones. There's going to be a quiz or maybe even a test this Thursday on all the rules of exponents.